Okay, this next video is going to talk about the derivatives of the cotangent function and the secant function. I'm going to do 2 and 1. So we're going to use the quotient rule. I'm going to write this as a quotient relationship of cosine x over sine of x. And the quotient rule is going to be used again. So the derivative of the first derivative is equal to low d high, so it's sine of x, times the derivative of cosine x, which is negative sine of x, minus the cosine of x times the derivative of the bottom, which is cosine x as well, all over low squared, which is sine squared x. So here I get negative sine squared x minus cosine squared x over sine squared x. If I factor out the negative 1, I get the Pythagorean identity, sine squared x plus cosine squared x, which is 1. So I have negative 1 over sine squared x, which is negative cosecant squared x. And that's the derivative of the cotangent function. Now over here, we have y equals secant of x. We write this as a reciprocal relation, 1 over cosine of x. And again, applying the quotient rule. So it's low d high, well the derivative of the constant is 0, minus high d low, the derivative of cosine x is negative sine of x, over low squared. So when I put the two negatives together, I get sine of x over cosine squared x. Splitting up the denominator, I get sine of x over cosine of x times 1 over cosine of x. And by quotient relations, sine x over cosine x is tangent x. Reciprocal relation, 1 over cosine x is secant x. So my derivative is tangent x times secant x, or, as you may see it, secant x times tangent x. And that's the derivative of the secant function.